a stress in concrete because there is a steel provided. So I also need to calculate what is this stress. Which stress? I need to calculate this stress sigma dash CBC. ये वैल्यू भी मुझे चाहिए क्योंकि जब भी मैं एनालिसिस करूंगी आई विल नीड दिस in the analysis as well as in the design. So how to calculate this? A very simple technique which we have calculated or which we have done earlier. This many a times this is asked in your orals. How do you calculate the stress in the concrete where at the level where the steel is provided? What is this is what sigma dash CBC. It is the stress in concrete at the level of the steel in the compression zone. जहाँ स्टील प्रोवाइड किया है वहां पर कंक्रीट में क्या स्ट्रेस आया है वो हमको कैलकुलेट करना है. So I will be using the similarity of
Ma'am,
triangle equation. Yes, yes, I got it. I got
ma'am,
it. Just a minute. This is the stress in the concrete, but when the steel is provided. So I am calculating the stress in the concrete at the level of the steel. Where it is in the compression zone only. So let us calculate this value. Now to get this value, we are using the simple trick which we have done earlier, that is equating with the help of the similarity of the triangles. As I need this value, as I need this value, that is the stress in the concrete, what I'm going to do is I'm going to compare these two. So let me say that this is XA and this distance is XA minus D dash. So I know this from the assumptions which we have made. I'm going to compare this with what? With the strain. So this will be epsilon C. Just a minute. Yes. So this will be epsilon C upon epsilon SC. That is the stress in the steel at the concrete. Just a minute. I am just changing this setting. Okay. So let me write the equation. Epsilon C upon epsilon SC will be equal to, it is XA upon XA minus D dash. From the similarity of the triangles, I am using this. Now I will just replace this. What I am going to do is I am going to change this. I can write epsilon C. You know that epsilon C is sigma CBC upon EC. Similarly, epsilon SC is equal to sigma SC upon है तो ये ऊपर चला जाएगा तो into ES for the steel is equal to XA upon XA minus D dash. Just replacing this two epsilon in terms of modulus of elasticity. Therefore, now I can get the value of sigma SC from this. So let me see that sigma SC is equal to, I need to replace it as per our condition which we have taken from the IS code. I need to replace this with 1.5 m. Before that, let me explain you. This can be written as sigma CBC. I'll just explain this later, otherwise you will get confused. Sigma CBC upon this whole term, that is EC upon ES. You know that this is the modular ratio. So I am going to write it as the modular ratio, and you know it is to be multiplied with 1.5. So 1.5 m into sigma SC. क्या किया वापस देखो, ये टर्म, this term, modulus elasticity of concrete divided by modulus of elasticity of steel. I know that this is modular ratio. तो मैंने उसको modular ratio में लिखा, और मुझे पता है उसको मल्टीप्लाई करना है 1.5 से, because it is specified in the steel IS code. So 1.5 m, और ये सिग्मा एस सी ऐसे ही रहा, तो सिग्मा एस सी को ऐसे ही लिख दिया. दिस इज इक्वल टू XA upon XA minus D dash. So I get this term. अभी इसको मुझे और सिंप्लीफाई करना है to get the value of sigma SC और मे बी सिग्मा CBC और सिग्मा डैश CBC. मुझे सिग्मा डैश CBC के टर्म्स में चाहिए, तो इसको मैं और सिंप्लीफाई कर सकती हूँ. सो लेट मी राइट सिग्मा SC इज इक्वल टू, सिर्फ मैं टर्म्स को अरेंज करती हूँ टू गेट द वैल्यू ऑफ सिग्मा SC. 1.5 m into XA minus D dash divided by, this will be divided by XA into sigma CBC. So from this I can say that, I'll just say that sigma SC is equal to 1.5 m XA minus D dash अपॉन x. जस्ट मैंने वही टर्म इधर लिखा है सिग्मा CBC. तो ये हुआ मेरा वैल्यू सिग्मा SC का. लेकिन मुझे क्या चाहिए, आई वांट द वैल्यू ऑफ सिग्मा डैश CBC. So let me say, if you see this equation properly, you can say that this value, just a minute. Yeah, okay. Now I can say that I need to write this in the terms of sigma dash CBC. So what I am doing, see, I'll write sigma SC is equal to 1.5 m into, I will replace this whole equation by sigma dash CBC. मैंने क्यों किया ऐसे वो देखो. If you look into this equation properly, XA minus D dash by X. So it is what? It is this term.
Ma'am,
XA
we can't
minus
look.
D dash. Okay, okay. Okay now?
Yes.
Okay. So if you look into this term, sigma dash CBC, this is nothing but I have replaced this by this XA minus D dash upon XA into sigma CBC. Now, if you see the diagram, you will find that it is this term XA minus D dash. So it is D dash for the area of the steel in compression. So I get this much part divided by XA. So it is again comparing these two stresses which are developed for the concrete as well as the steel. So I say that sigma dash CBC, ultimately you get this from the diagram also. XA minus D dash upon XA into sigma CBC. Even if you compare the diagrams, if you write the similarity of triangle for that, you will get this.